video we will discuss about sampling process and also discuss about the sampling theorem. So I have used my own notes for this video. You can also copy this one. Okay, let's start with the sampling process first. So the basic explanation about the sampling process is it is the process of converting a continuous signal xt into an equivalent discrete time signal called the sampled signal. In this process, we send an analog signal into a device called the multiplier, where we apply the continuous time signal xt as an input to the multiplier, and also the multiplier itself gives a predefined signal called the sampling signal st, and the multiplier multiplies both these signals and produce an output called the sampled signal, which is the combination or the multiplication version of xt and st. So this is our continuous time signal xt, and this is the sampling signal st, where there are multiple samples, and when the multiplier multiplies these two signals, it produces the sampled signal, which looks like this one. The value of the signal is measured at equally spaced time intervals, and the each measure of the value is called a sample. Each each is called a sample, and the number of samples taken per second is also called the sampling frequency or the sampling rate, which is given by fs equal to 1 by ts. So this is what sampling is. We send an analog signal to occur at a particular time interval called the sampling. So the process of converting is continuous signal into an equivalent discrete time signal is called the sampling process. Now let's see the sampling theorem. It is the most important question here because it comes every year. The sampling theorem states that a continuous time signal xt can be completely represented in its sampling form, which is kind of like this, and recovered back from the sample from this to this if the sampling frequency fs is greater than twice fm, or also the modulating frequency, which is mathematically given by fs greater than twice fm, where fm is the maximum frequency of the continuous signal. The maximum, this is fm, the maximum value of the continuous signal or frequency of the continuous signal. So the explanation of the sampling theorem is simple, where we can convert a or represent a continuous signal into its sampling form this signal, and also recover the continuous signal from this to this. Again we can get this to this, and again get from this to this, if nothing but the sampling theorem fs, if only if the sampling frequency fs is greater than a twice fm. If we satisfy this equation or the expression, we can convert a continuous signal into a sampling it in its sampled form, or we can also recover the original signal from the sampled form.